Hello class. Today what we're going to talk about is inequalities in two triangles. In the previous video we looked at inequalities in a single triangle, right? So we looked at how these compared the angles based on the lengths of the sides, and the lengths of the sides based on the measures of the angles. We could see which triangle was bigger than the other triangle, or which angles were bigger based on the lengths of the sides. What we're going to look at in this video is between two different triangles. Okay, and before we really get into that, what we want to look at is think about a gate. Okay, triangles, we're looking at gates. Yeah. Look at a gate. So here we have a gate. The fence posts are at point B and point A, and here we have the gate, and we'll call the end point of the gate point C. All right, and the gate can swing open and close and all of that. And as it does, the distance between point A and point B doesn't change. Right, it stays what it is. And the length of the gate also doesn't change. It stays the same length, right? Because that'd be weird if your gate got shorter as you opened it, right? However, if you see here, the farther we open that gate, AB is the same. AC is the same. However, BC changes because the end of that gate to where it closes gets farther and farther away, right? As you open it. The wider that gate is, the longer this distance. All right. And so we see here we have three different triangles. AB is the same in all of them. AC is the same in all of them. But BC is different. All right. BC gets longer and longer the wider we open the gate. So the bigger this angle A is, the longer side BC gets. All right, as it opens up on the hinge. And that is why we call this the Hinge Theorem. All right. What the Hinge Theorem says, if two sides of one triangle are congruent to two sides of another triangle, and the included angle of the first triangle is larger than the included angle of the second, then the third side of the first is longer than the third side of the second. That was lovely, right? Let's go over this and break this down so we can kind of like digest it and see what it's saying. So if two sides of one triangle are congruent to two sides of the other, so here we see two sides are congruent to those two sides, right? This is like in the gate, this AB is congruent to and AC is congruent in each other. Okay, so we have two triangles, we have two sides in one triangle congruent to two sides in another triangle. Right? And the included angle of the first is larger than the included angle of the second. The included angle, if you remember, that is the angle that is formed by those two sides. All right, so that's angle V here, angle R there. In our gate situation, that's angle A. All right, so it's saying if angle A is larger in this triangle than it is in this triangle, all right, so this included angle, angle V, is larger than angle R, then the third side of the first is longer than the third side of the second. All right. So over here, since angle A is bigger, BC is longer in this triangle than it is in this triangle. All right. So over here, since these two sides are congruent to those two sides, then since angle V is larger than angle R, then WX is longer than ST. This third side is going to be longer than that third side. That's the Hinge theorem. That's what it says. The important thing here is that you have two congruent sides and the angles that are in between those two congruent sides. Okay, this doesn't tell us anything at all about those other two angles. All it tells us about is the included angle and that third side. Converse of the Hinge theorem says, well, you know what? If you have that same situation where you have two triangles with two sets of congruent sides, then if that third side is longer in one triangle than it is in the second triangle, then the included angle is going to be larger in the first triangle than it is in the second triangle. Okay, it's basically just taking the opposite way around. It says, hey, you know what? If you got those two sides that are congruent, then if the third side is longer, then that angle is going to be bigger. All right, that's what we're saying. just the opposite of the Hinge theorem, because that's the way converses work, right? Okay. So, important thing, you have to have two sides congruent, and then you're going to be looking at the third side and the included angle. Okay, you're either looking at, okay, which one has the longer side or which one has the longer angle. And in both cases, the largest angle goes with the largest side. The largest side goes with the largest angle. Smallest angle has the smallest side, smallest angle. All right, so let's take a look at some examples with this, see what we can do with it. All right, so for exercises 1 through 9, we're going to complete the statement with less than, greater than, or equal to, and we need to explain our reasoning. Okay, so for number 1, we are going to compare segment BC with segment EF. So let's see, BC and EF. So we're looking at these. We're going to look at the angle opposite them. All right, and that will help us if and only if we have two sets of congruent sides. Right? And we do. AB is congruent to DE, AC is congruent to DF, and so we can look at this and this will work. So first we have to explain everything. So since segment AB is congruent to segment DE, and segment AC is congruent to segment DF, then looking at this, which one's bigger? Okay, since we have these two congruent, that means the Hinge theorem is going to work, right? So D has a bigger measure than A. So the measure of angle D is greater than the measure of angle A. So then we can use the Hinge theorem. So that's what we're going to write it down here. Hinge theorem. So by the Hinge theorem, since D is bigger than A, then the side opposite D, EF, is bigger than the side opposite A, BC. So EF is greater than BC, so BC is less than EF. All right, so not too bad. What I would like for you to do is pause the video and go ahead and do 2 and 3. All right, so you're back. Let's see how you did. Let's see here. So we need to compare BC and EF. So the same things again. Looking at this, we have to have two sets of congruent sides, which we do. These two are congruent. Those two are congruent. So what's our biggest angle? A is bigger than D, right? Because 95 is a lot more than 20. So the measure of angle A is greater than the measure of angle D. And so we're going to use the Hinge theorem again. Hinge theorem. And so we know that since A is bigger than D, BC, opposite A, is going to be bigger than EF, which is opposite D. Remember, the side opposite the big angle is bigger. All right, so let's take a look at BC. Number 3, again, BC and EF. Let's see here. Do we have two sets of congruent sides? Yes, we do. So we have two sets of congruent sides. And I got to have that. Congruent sides. Let's see the included angles. We have angle A is a right angle. Angle D is 90 degrees. That's the same thing, isn't it? 90 degrees, right angle, they're the same. So here we have angle A is congruent to angle D. Now, so is this going to let us use the Hinge theorem? No, it's not. Hinge theorem says one has to be bigger than the other. And it's not bigger, it's congruent. So what do we have? Well, we have side, angle, side, congruent to side, angle, side. This is SAS congruence. SAS congruence theorem, they're going to be congruent. So these angles are going to be equal to each other. All right, let's take a look at this next set. See how we do. All right, so here on this next set, we are not comparing sides, we are now comparing angles. So, looking at the angles, angle A compared to angle D. Let's see, angle A compared to angle D. Are the sides that make up those angles congruent? Yeah, that side's congruent to that side. These two sides are congruent, so that's good. And so now what we're going to do is look at the opposite side, and oh, look at that. Those are congruent as well. We have all three sides congruent to all three sides. So that means what we have is side, side, side congruence. These two triangles are congruent to each other. And therefore, that means the angles are going to have the same measure, aren't they? Yeah, that's CPCTC. CPCTC. All right? So these measures are going to be equal to each other because they're congruent. The opposite sides are equal. All right. So let's take a look at angle A and angle D on number 5. Let's see. So angle A and angle D are the two sides that make up those angles congruent. Let's see. AB is congruent to DE. AC is congruent to DF. So yes, the two sides that make those angles are congruent. Let's look at the sides opposite those angles. And 14 is bigger than 16. Nope, 14 is smaller than 16. Said it backwards. So BC is smaller than EF. The length is shorter, right? And so since BC is shorter than EF, angle A, which is opposite BC, is going to be smaller than angle D. How about you pause the video and you do number 6 on your own, then come back and check it. All right, let's see how you did. All right, so comparing A and D, the two sides that form those two angles are congruent to each other, right? And so let's see. Oh, I forgot to say which theorem this was. This is the converse of the Hinge theorem because we're going from the side to the angle. Converse of the Hinge theorem. Hinge theorem. All right. So let's look at this. Look across the triangle, opposite of angle A, we have 9 units there. Opposite of angle D, we have 2 units. So BC is greater than the length of EF. Therefore, again, this is converse of the Hinge theorem. Or another way you could write this, this is the Hinge theorem converse. So since this one's bigger, angle A is going to have a larger measure than angle D. Right. Remember, larger angle is opposite the larger side. All right, let's try 7, 8, and 9. Okay, so these triangles are set up a little bit different. That's okay, we can still do this. So segment AB and segment AC. Okay. What we need to do is make sure the other two sides are congruent pairs, right? So BD is congruent to CD, those are marked. DA would have to be congruent to DA. I mean, it is, it's the same side, right? So it's reflexive. So we do have two sets of congruent sides. So now we look at the angle opposite the two sides we're looking at. And 145 degrees is greater than 135 degrees. So the measure of angle BDA is greater than the measure of angle CDA. And so we're going to say that the side opposite the bigger angle, BA, or AB, is greater than the side opposite the smaller angle. There we go. And we need to explain this is the Hinge theorem or the converse. Yeah, it's the Hinge theorem, right? Because we're going from angle to side. So this is the Hinge theorem. All right. So let's take a look at number 8. Number 8, we're looking at AB and CD. So we look at the opposite angles and, oh, well, those are congruent to each other, aren't they? And the sides that make up those angles are congruent to each other. So we have side, angle, side right here. These triangles are congruent. Side, angle, side. Congruence. These are going to equal each other. Because they're equal. Equal angles, equal sides. If the other two sides are congruent. So we've got congruent triangles, so we have congruent angle sides. Same length. All right, number 9, what do we got here? We're going to compare the measure of angle 1 to the measure of angle 2. So we got to make sure that the sides that form those angles are congruent. So that would be AC and CB, congruent to BD, yep, and BC, well, CB and BC, those are the same side, it's reflexive, so yeah, we're good there. So, since the two sides that make those angles are congruent, we need to look at the sides opposite that. So, AB and CD. Let's see here, CD is 19, AB is 17, so the length of CD is greater than the length of AB. So since we're going from side to angle, this is going to be the Hinge theorem converse. Hinge theorem converse. And that should be in parentheses. Converse says that CD is bigger, so this angle opposite CD, angle B is going, or angle 1 is going to be larger. There it is. All right, so there it is. That's a nice intro to this. Let's take a little bit closer look. All right. We are going to write some proofs. I know we haven't done proofs in a while, but that's okay. These are pretty simple ones, and you got to remember how they're done. All right. So we are going to do this as a 2-column proof, just because that's the way I like to do them. You could do this as a flow proof or as a paragraph proof, whichever one you want. That's fine. I just like 2-column proofs, so I'm going to do 2-column proofs. You have statements on the left, reasons on the right. Statement 1. All right, now we're set up. Let's see what we're proving. We are given that segment XY is congruent to segment YZ. We are given that the length of WX is larger than the length of WZ, and we're going to prove that the measure of angle WYX is larger than the measure of angle WYZ. So we're going to prove this angle is larger than that angle. We're given some stuff. So let's start by writing down our givens while we think up a plan of what we can do. Let's see. YZ, and we know that the length of WX is greater than the length of WZ. We know this because it was given to us. Okay, so we need to prove two angles are unequal. One is bigger than the other one. So this is, we're looking for the Hinge theorem, right? Or the converse, right? Because we are trying to prove the angle, so we're looking at the converse of the Hinge theorem. And so, for that to work, the sides that form that angle have to be congruent. So we're looking at this angle and that angle. The side that forms this angle, that would be XY and WY, congruent to ZX, or ZY and WY. Well, XY and ZY, we know those are congruent. We've already said that. So we just need to say that WY is congruent to WY. Is it? Sure it is. It's the same thing. That's the reflexive property. So WY is congruent to segment WY by the reflexive property. Reflexive property. All right. So now that we have said that we have two sets of sides congruent to each other, we have already, and we're looking for the included angle, we've said that the third side, WX, is more than the length of WZ, so that means the included angle of the first triangle is going to be larger than the included angle of the second triangle. So we can go and say that. So the measure of angle WYX is greater than the measure of angle WYZ. Kind of ran out of room there. There it is. And how do we know this? This is the Hinge theorem. Is it the Hinge theorem or is it the Hinge theorem's converse? Which one is this? Well, let's see here. Just got to remember. Okay. Let's see. Hinge theorem starts with the angle, conclusions about the sides. Converse starts with the side, conclusion about the angle. So we are starting with the side, concluding about the angle. So this is going to be the converse. C-O-N-V. Converse. And there it is. That's it. That wasn't too bad. All right. So let's take a look at number 11. Actually, you know what? How about you pause the video, you work out number 11, then come back and see how you did. All right. Number 11. Let's get set up here. You're back. We've got statements. We've got reasons. Statement 1. is, of course, our given information. Given segment AD is congruent to segment BC, and that the measure of angle DAC is greater than the measure of angle ACB. That's given to us. Given. Alright, so statement 2. Again, we're going to look for Hinge theorem because we're trying to prove one thing is bigger than the other. So we're looking at the Hinge theorem. And in order for that to work, we're saying DC and AB, right? So we look at the angles across from each other, which is these angles here that we said. In order for this to work, we have to know that the sides that make up those angles are congruent to each other. Okay? Otherwise, it's no good. So let's see. The side that makes up angle DAC would be AD and AC. The side that makes up angle ACB is angle BC and AC. So we know these two are congruent. We've already said it. That was given to us. Now what we've got to do is show that that one is congruent to that one. And, well, of course, AC is congruent to CA. It's the same thing. AC is congruent to segment CA. Its reflexive property, again, just like it was in number 10. Reflexive property. Alright, and now that we have said that we have those two sides, and we've said that the included angle of this triangle is larger than the included angle of that triangle, that means the third side, DC, is going to be larger than the third side of the second triangle, AB. So the length of DC is greater than the length of AB by the Hinge theorem. Was this the Hinge theorem, or is this the Hinge theorem's converse? Yeah, that's right. This is just the theorem. Because we started with the angle. We already had information about the angle, and we made conclusions about the sides. So this is just the Hinge theorem, not the converse. All right. So now, let's take a little look at application. All right. How can we use this? Well, it's good for some stuff. So here we go. We're starting from point 10 miles north of Crow Valley. A crow flies northeast for 5 miles. Another crow, starting from a point 10 miles south of Crow Valley, flies due west for 5 miles. Which crow is farther away from Crow Valley? Explain. Okay, so we got north, south, east, west, all that stuff. So real quick, I'm going to just draw me a little compass rose right here. All right, we've got north, south, now north, south, east, west. Never eat sour watermelon. Okay, so we are going to start from Crow Valley. That's a common point between the two crows. So right there, we'll call that V for valley. Okay. First one starts off 10 miles north. So we're going to go 10 miles north. We'll call it right there. 10 miles north, straight up. Then flies northeast for 5 miles. Okay. So to do northeast, what's actually happening here is it turns northeast, which would be halfway between north and east, right? So that means it's going to make a 45-degree turn and go this way. So right there, this is 5 miles. And this is, we'll just call this the North Crow Inn. Now let's take a look at the second crow. This crow started south for 10 miles. 10 miles, south, down. And then went due west. So due west is just going straight over. Nice little 90-degree turn here. So 90-degree turn, right angle, and went 5 miles. And we'll call this the South Crow, S. So the question is, which one is farther away from the valley? So we want to know which is longer, NV or SV, the North Crow or the South Crow. Now they both went 10 miles and then 5 miles, right? So we need to look at that angle on the inside, right here. Well, here, this crow turned 90 degrees. This crow turned 45 degrees. However, notice that 45 is not inside the triangle, is it? No, that's how far it turned. So what we need to know is what's inside the triangle. Well, this is a linear pair, which means it's supplementary. Adds up to 180. So 180 minus 45 equals 135. So that means this is a 135-degree angle. So now, which angle is bigger? Yeah, that one's bigger. The 135-degree angle is bigger. So which crow is farther away? Well, the one that had the bigger angle, right? So we're going to say the North Crow is farther away. North Crow is farther. North Crow is farther. Explain. Well, that angle, we'll just call this A and B. The measure of angle A is greater than the measure of angle B, and so this is the Hinge theorem, not the converse. Started with the angles, ended up with the sides. So, according to the Hinge theorem, the North Crow is farther than the South Crow. All right? Okay. These can be kind of tricky. Remember, you are looking at the angle inside the triangle, which is not necessarily the angle that the crow turned, or whatever it is you're looking at. You've got to draw the picture. If you don't draw the picture, you will mess up very, very easily. Okay. All right. So there it is. This is the Hinge theorem. The important thing to remember is you must have two sides of one triangle congruent to two sides of the other triangle. You have to have that. Then the side that is opposite the largest angle is going to be the largest side. And you also have to remember this tells you no information about those other two angles. All right? Anyhow, I hope you found this helpful, and I'll see you next time.